The following is an instructional video on how to solve a systems of equations using the Gaussian elimination method. The idea of using the Gaussian elimination method is to use just the coefficients of the variables plus the constant and putting them into a matrix. So that's the first step that I've done here. I've taken these three or the coefficients plus the constant and place them into the first row of this matrix, and then likewise I take the coefficients of the second equation plus the constant and put them in the second row of this matrix. And the idea is to convert this matrix into a matrix that looks like this, where all the elements are or rather the first two columns, all the elements are 0 except for the diagonals that are equal to 1, and then the remaining column are actually going to be the answers to or our solution to the system. So we begin with starting from this matrix. I want to be able to have the first row and first column, or the first element of the first row, first column, be equal to 1. So I can easily do that by switching the second row with the first row. So that's exactly what I've done in this step. I've just taken the second row and replaced it with the first row. And next we want to convert this element, this 3, into 0. So one way I can do that is by taking the first row, multiplying it by -3, and adding it to the second row. So there's a step for that. I take row 2 becomes -3 times R1, or row 1, plus row 2. So when I do that, this element becomes 0, and then -3 times 2, which is -6, plus -1 becomes -7, -3 times 10, which is -30, plus 2 becomes -28. Next, I want to convert this -7 into 1. So one way I can do that is by taking row 2, dividing it by -7. And that's what I've done in this step here. I take row 2, divide by -7, and this becomes 1, and this element becomes 4. The last step is to convert this 2 into 0. I want to be able to convert this 2 into 0. So I can do that by taking the second row, multiplying it by -2, and adding it to the first row. So when I do that, this becomes my new matrix. This matrix is now in the Gaussian elimination mode, and the first the last column is actually the solution to our system. So as you can see, the system to this, or the solution to this system, is this last column, which is x sub 1 is equal to 2 and x sub 2 is equal to 4.